Hi everyone, this is Kevin. Before we start the video, I have to make a deep apology. Here's what happened. I've made a serious mistake in the video. The data transfer speed should be in gigabytes per second, but I kept saying gigabits throughout the entire video. Yes, I realize that this could affect your viewing experience a lot, and please do forgive me this time. I'll pay more attention in the future. Again, sorry for this silly mistake that I've made, and a big thank you to Bill, who pointed that out. That's all I want to say, and I hope you guys enjoy the rest of the video. In this demo, we are using 8 A100 GPUs, one Falcon 4010 GPU chassis, and PCIe Gen 3 and Gen 4 server of 1 each. The CPUs are Intel Xeon Gold 5120T and AMD EPYC 7442 respectively. We have installed the graphics cards in our expansion chassis and connecting the chassis to the two hosts. So the system topology is shown as the diagram. So we have installed the graphics cards in our expansion chassis and connecting them to the two hosts. We have assigned each host 4 A100 GPUs. And you can see from our graphical user interface, we have this AMD EPYC CPU recognized. And under the resource management, we have 4 A100 connecting to it. And if we check it from the host end, we'll find the same 4 GPUs. We'll run the P2P GPU bandwidth latency test. Okay, with P2P disabled, the performance appeared to be around 15 gigabits per second unidirectional and 16 gigabits per second bidirectional. And with P2P enabled, it's around 24 gigabits per second unidirectional and 48.6 bidirectional. And you might have noticed that the transfer speed appeared on the graphical user interface is a little bit higher. That is because it is the size of actual data plus the data package. The bidirectional P2P performance is steady at around 48.6 gigabits per second. Okay, now we'll check out the host-to-device performance. We'll have to let it run for a bit. Okay, so it appears to be steady at around 27.2 gigabits per second. Mhm. Next, we'll check out the device to host. Okay, so now we have let it run for a bit, and we see that the performance is again steady at 27.2 gigabits per second. Now let's check out the bidirectional host-to-device performance. Okay, so now we can see that the number is steady at around 30 gigabits per second. Now let's run peer-to-peer GPU performance for two GPUs first. Okay, so we have let it run for a bit, and we can see that the bidirectional peer-to-peer performance appears to be around 48 gigabits per second. And then we'll run the peer-to-peer bidirectional performance for all four GPUs. Alright, so as you can see, we get similar results. The performance is at around 48 gigabits per second again. So we've run exactly the same procedure for the Intel Xeon server, but we thought it would be boring for you to see that again, so the test results are presented in this table. As you can see, the bandwidth performance under Gen 4 environment is pretty much doubled in comparison to the Gen 3 environment. However, the latency appears to be the same for both environments. That's it for today's video. Thank you so much for watching.